Hi folks, welcome to 6.1 Verifying Trigonometric Identities. So this is going to be a good chance to review some old content that you learned way back when you took Trig, and we're going to be revisiting things like sine and cosine and tangent and all the other fun functions that are within trig identities. Okay. So we're going to start with the fundamental trig identities. Now, I would really suggest that these are ones that you know and, more importantly, that you love. They come up quite a bit, and so it's the more you know them, the easier it is to think, okay, which one should I use when? So let's get started with our reciprocal identities. Now, these are ones that you learned way back when you learned about not just sine, cosine, and tangent, but that there's other trig functions as well. And so let's go ahead and get started. The first pair of reciprocal identities is sine and cosecant. So sine we can say is 1 over cosecant theta, and cosecant we can say is 1 over sine theta. The second pair of reciprocal identities or reciprocal trig functions is cosine and secant. And we can say that cosine is 1 over secant theta, and that secant is 1 over cosine theta. Okay, let's take a look at our third pair of reciprocal identities. So we've got tangent and cotangent, and we can represent tangent as 1 over cotangent theta and cotangent as 1 over tangent theta. So there you have your three pairs of reciprocal identities. Let's talk about our quotient identities. So our quotient identities take our reciprocal ones and take them one step further. So if you think back to when you learned about the unit circle, you might remember that sine and cosine were on your unit circle, but tangent, you had to do a little bit more work to find it. And so we know from our unit circle that the x values on the unit circle correspond to cosine theta. And what that means then is y values on the unit circle, they correspond to sine theta. So how do we get tangent? Well, we're just going to take sine theta and we're going to divide it by cosine theta. That will give us our tangent. And to find cotangent, we'll take the reciprocal of that, which is cosine theta over sine theta. Okay, moving on. Let's take a look at our odd-even identities. So as it turns out, only 2 of these functions are even, and the other 4 are odd functions. So let's refresh ourselves on what it means to be an even function and an odd function. So an even function means that f of negative x will equal f of x. In contrast, an odd function means that f of negative x will equal negative f of x. Okay. So let's apply these definitions to our odd-even trig functions. So our even pair, the even pair of trig functions are cosine and secant. So of all 6 of these trig functions, cosine and secant are the even ones. That means cosine of negative theta is going to equal cosine of theta, and secant of negative theta will be secant of theta. that means that the other 4 pairs are odd. So we've got this one as an odd pair, and at the very bottom, our tangent and cotangent are also odd. That means that all of these won't equal the f of x, but they will in fact equal negative f of x. So we'll have a negative sine theta here. We'll have a negative cosecant theta here. We'll have a negative tangent theta here, and a negative cotangent theta here. All right, I'll give you a moment to write all of that down before we move on. So we've got even functions, we've got odd functions. And we've got something called cofunctions. So our cofunctions also come in pairs, and some of you might notice that when I say sine, it's sine, but cosine is like sine, but with a co in front. That's how we know that things are pairs of cofunctions. So let's take our first pair of cofunctions, sine and cosine. So sine of 90, or pi over 2 minus theta, is going to equal cosine of theta. And cosine of pi over 2, or 90, minus theta, is going to be equal to sine theta. Now this might actually be easier for you to visualize if you take some time to plug in some numbers. So I'm going to say, let's make sure our calculator is in degrees. And let's try this with some degrees. So let's say I had sine of 90 minus 20. Type that into your calculator, see what you get. And then separately, I want you to type in cosine of 20. Are you getting the same number on both sides? Well, you should be. Sine of 70 should equal cosine of 20. And we could try it with the other pair, other half of the pair. We could try cosine of, let's do 90 minus 60, and say, is that equal to sine of 60? And I'll give you a moment to type that into your calculator, but when you do, you should find that those two are equal. Okay, so that's where the cofunction identities come from. Now we have a few more pairs. We have our tangent and our cotangent are also cofunctions, which means tangent of, this should say pi over 2 minus theta, is going to equal cotangent, and cotangent of pi over 2 minus theta is going to be tangent theta. And our final pair of cofunctions we have here, we have cosecant and secant. And so cosecant of pi over 2 minus theta will equal secant of theta, and secant of theta of pi over 2 minus theta will equal cosecant theta. Okay, so we're going to finish up this first part of the video with Pythagorean identities. And there are 3 Pythagorean identities that we'll talk about on the next slide, but more importantly, I want us to think about how do we get all of those identities. Okay, so the Pythagorean identities. Let's go back to when you first learned about right triangles. And you would call this side A and this side B and this side C. And you knew that a squared plus b squared equals c squared. And so we're going to take that and apply it to the unit circle and think about how things might correspond. So if I have an angle in the first quadrant, it actually comes from a triangle that is a right triangle in the first quadrant. And the sides of our triangle, we're not going to call them A, B, and C anymore, but the horizontal side, we're going to call X. The vertical side, we're going to call Y. And then what's special about the unit circle is the radius of the unit circle is always 1. And so we get x squared plus y squared equals 1. Okay, now if you go back a few slides, I hope you remember that I said that the x values on the unit circle are cosine, and the y values on the unit circle are sine. And so what we're going to do is we're going to substitute in, instead of x, we're going to say cosine. Instead of y, we're going to say sine. And we'll get cosine squared theta plus sine squared theta equals 1. And this is our first Pythagorean identity. And I would say that one is definitely worth memorizing because it comes up quite a bit. But let's talk about where the other two Pythagorean identities come from. Okay, so we're going to take our Pythagorean identity and we're going to go ahead and divide every single term by cosine squared and see what happens. So, divide by cosine squared theta. So I will get cosine squared theta over cosine squared theta plus sine squared theta over cosine squared theta equals 1 over cosine squared theta. Let's see what cancels. Cosine squared divided by cosine squared will leave me with 1. And sine squared divided by cosine squared, if you go back up to the very first, the second set of identities that we learned, the quotient ones, I hope you remember that sine over cosine is tangent, so sine squared over cosine squared is tangent squared. And if you go way back to the first set of identities we learned, 1 over cosine is the same as secant, so 1 over cosine squared is the same as secant squared. And here we have our second Pythagorean identity. Okay, let's go back to our original. And this time, we're not going to divide by cosine squared, we're going to divide by sine squared. And let's see what happens. Cosine squared theta over sine squared theta plus sine squared theta over sine squared theta equals 1 over sine squared theta. Now, using a lot of the same kind of thinking, we can turn sine squared over sine squared into 1, and we can use the quotient identity to simplify this one and the reciprocal identity to simplify that. And when we do that, we will get cotangent squared theta plus 1 equals cosecant squared theta, and that is our third and final Pythagorean identity. So I'm going to stop here, come back for video part 2, where we're going to go through some examples of how to use these identities. See you there.